Welcome to Ask and Learn.
In this question, we are asked to show that lexicographic order is a partial ordering on the set of strings from poset. So here it doesn't mean just characters or number, it's any poset S with its own partial ordering. We will have element in S, right? Suppose call it A1, A2, and so on. String here mean any combination of elements that we want. Suppose we write this in some combination, and this will be a string of elements from a poset. And the set of all such words are what we are considering. So let's go over lexicographic. For a string A and B, I will call it A1 to AN, B1 to BM. And the way we compare two words is that first, if they are equal, so they are the same, then we are done. We have A and B related. The other way is that it's strictly one thing is strictly less than the other. In this case, we will look at the minimum of their length, and one of the two things have to happen for A to be less than B. Either within the minimal length, A is strictly less than B, or they are equal, but the word B itself is longer than A. So the second case, it may be that suppose for English letter, we have A, B, C, C, D, and A, B, and that's it. If we have it like this, then the second word is less than the first word just because the length is lower. Okay, the two position here are the same, and that's how we have, let me delete this, that's how we have relations. Either they are equal or one of the two things happens. So let's go over the property of partial ordering. First, reflexive. Obviously, any word will relate to itself. Anti-symmetry. Suppose two words A and B have their relation both ways. So I will use contradicting argument that if they are not equal, when these two things happen but they are not equal, then we must have either one or two, which are both impossible. One is that the string of length minimal, like of length t, are both less than and greater than each other, which is impossible, right? The other is that between the minimal length, the words are the same, but then the length of A is both lower and greater than the length of B, which is not possible as well. So by supposing this, we are led to impossible situation. So it's not true from the start. We must have that A equal to B. So anti-symmetry property is true. Last one is transitivity. So suppose ABC are the words written like this, and let the minimum length be in H and T. When we have these two properties, if any of the pair is equality, so either A equal to B or B equal to C, then we are done, because we will automatically, it will become just comparing two things, and we will have A related to C very easily using the fact that each entries are from a poset. Now we are left to show what's the case when they are strictly less than the other, right? So let's go over this. When both A is strictly less than B and B is strictly less than C, that means we'll have these two branches kind of that we established early on, right? When strictly less than relation happen, then for each pair, this one of two things have to happen. Now consider two cases. First, if T is less than or equal to H, here means as just normal integers, then we are done as well, because when this happens, we can directly compare A and C using the fact that its entry are from S, which is transitive because S is a poset. All right. If you are confused about this, you can pause and try to work it out. You will see easily that this is the case. If, on the other hand, if T is greater than H, so the last case that we are left with, that means that since T is minimal of N and M, right? H can be M. I will write it like this. H can be M because we have T greater than H and T must be less than M or equal to M. And so the second choice here can happen. So we must have the above choice for the pair BC, right? This lead to this inequality. And once we have this, it doesn't really matter what happened on the pair AB side. It can be the first, it can be the second choice, because again, S is transitive and C is strictly greater than B for this length. Then C gonna be greater than A for this length as well. And so the words A will be less than B in both cases. And so we have proved the transitivity. Okay. And so we have proven three property of partial ordering. And so we are done. That is it. Thank you.